In this section, we're going to solve a system of equations. Now, a system of equations with two variables has multiple solutions, and the solutions are actually the graph of each of the equations. So when we graph a line, for instance, in this first example here, y equals negative x plus 4, we have a slope here of negative 1 and a y-intercept of the point 0, 4. That can enable us to graph this. Now 0, 4 is a solution because if we replace x with 0, the y value has to be 4. Now we can use our slope to get some other points. The slope is negative 1 over 1, which means we go down 1 for every time that we go over 1. And this other point, which is 1, 3, is another solution because in this equation right here, I'll highlight the equation we're working with, if you replace x with 1, negative 1 plus 4 is 3. So that solution works in that equation. The trick is to find the solution that works in both equations. And to do that, we're going to graph each line. So I'm going to finish graphing this one line right here. And I'm going to graph as many points as I can so we have a very accurate graph. Accuracy is very important when you're solving a system of equations. Can use a straight edge. That's going to be hard for me to do in this video. All right, let's check out the second equation. The second equation is x minus 2y is equal to negative 2. Now that's not solved for y just yet, so we have to solve it for y. I'm going to subtract x from both sides of the equation. So now we have negative 2y equals negative x minus 2. And then I'm going to divide both sides by negative 2, being careful to distribute that division to both of the terms in the right side of the equation. So that gives us y is equal to positive 1/2 x plus 1. So that means our slope is 1/2 and our y-intercept is the point 0, 1. So I'll graph the point 0, 1 and then use a slope of 1/2. That's going to be a rise of 1 and a run of 2. That's a positive slope. So as we go from left to right, the line rises. And I'm going to graph as many points as I can to ensure my accuracy here. Connect those. It's important when you're graphing, we don't want to stop short of graphing both lines. That's an important thing. That's going to be part of your answer. Now you can see within the limits of our graphing accuracy here that there's a common point. That's the point of intersection. And that point of intersection is the point 2, 2. So what that means is, hopefully, 2, 2, x equals 2 and y equals 2 works in both equations. Let's do a quick check to make sure that that's the case. So in the equation number 1, if we replace the y with 2 and the x with 2, we get a statement that's true. Negative 2 plus 4 is positive 2. And let's check out statement number 2. Replace the x and the y with 2, and we get 2 minus 4 is equal to negative 2, and that's also true. Make sure that when you check your solutions in the original equations. That way, if there's a problem, we can have done a couple of things wrong. We possibly could have graphed the line wrong, or we could have solved for y wrong. So it's important to check for those things. Also important is to note what your solution is. Here's the point 2, 2. Give it an ordered pair form. All right, let's check out one more example. We'll do this one a little bit more quickly. So we're going to graph both lines. Let's graph 2x minus y is equal to 7. That's not solved for y, so we need to subtract 2x and then divide by negative 1. And that's going to give us y equals positive 2x minus 7. That has a slope of 2 and a y-intercept 0, negative 7. All right, let's put that on our graph. So start with the point 0, -7, and a slope of 2 is 2 over 1, so that means we go up 2 for every time we go to the right one. So going to the right one and up 2 provides us with lots of points to graph. We don't know where that intersection point is going to be, so it's important to have an accurate graph throughout. All right, let's check out the second graph. The second graph is a really special kind of equation, x equals 6. Notice there's only one variable in it. That means it's going to be easy to graph. I'm going to encourage you to use a table of values, and what the equation says is x has to be 6. So I'm just going to write 6 for both points, and then I'm going to make up a couple values for y. It doesn't matter what y is, as long as x is 6. So 6, 0 is 1 point, and 6, 1 is another point. Now if we graph that, that means that's going to be a vertical line. And we can see that the point that these two graphs have in common are the point 6, 5. So our solution is 6, 5. Let's check it in both equations. In equation number 1, if the x value is 6 and the y value is 5, hopefully that works out. 12 minus 5 is 7, check. In equation number 2, there's only x to replace, and 6 does equal 6. So that checks. All right, let's do a couple more that have some special situations in them. So in C, we have 6x minus 3y is equal to 3. Let's graph that one. But first we've got to solve for y. So 6x minus 3y is equal to 3. Subtract 6x. And now we're going to divide both sides by -3. It gives us y is equal to positive 2x minus 1. So we have a y-intercept of 0, -1, and then we have a slope of 2, which is 2 over 1. So that means when we go over 1, we go up 2. So now I'm going to connect those points. Use a different color here, just so we can see it better. All right, now let's check out the second equation. That's 2x minus y is equal to 7. Let's subtract off 2x from both sides and divide by -1. And we get y equals positive 2x minus 7. Okay, so let's check out that. That's going to have a slope of 2 still, 2 over 1. But its y-intercept is 0, -7. So if its slope is the same, still every time we go over 1, we go up 2. And let's graph this. Now the special thing that happens here is, since these two equations have the same slope but different y-intercepts, they are parallel lines. And we are looking for the solution that makes both equations true, and that would be the point where they intersect. Since there is no point of intersection, there is no solution. Make sure that you write no solution here and not parallel, because we're looking for the solution, so parallel is not a solution. Okay? All right, now let's check out another example. In D, x plus y is equal to 3, so x plus y is equal to 3. We need to solve that for y. That's just subtracting x from both sides. And since we've already got y by itself on the left side, that means we have a slope of -1 and a y-intercept of 0, 3. So every time we go right 1, we go down 1. Graph all of those points. And let's check out equation number 2. Equation number 2 is 2x plus 2y is equal to 6. So if we subtract off 2x and then divide both sides by 2, y equals negative x plus 3. Now what you may realize is that's the equation that we just graphed. So if we were to graph the other equation and say where do these two lines cross, they cross in every point on the line. So that means there's not just one solution, but there is an infinite number of solutions. And those solutions are all the points that are on the line, and there's an infinite number of them. We can certainly name several. For instance, 0, 3, 1, 2, 2, 1. All of those work in both equations. And that's it for this part of the lesson.